make it so that there you put a little effort in. Yeah, spun it around the axis. So we're looking at last week of April. So we're going to do changing forms of conics this week. Formative this week because we had a quiz last week. So we'll do formative on the alternating system. Next week, I'm looking at doing conic systems of equations on Monday, Wednesday, and Thursday. Possibly, I don't know. I don't know yet if we're going to do the test on the 5th on Cinco de Mayo, or if we're going to do the test on May 8th, which would be a Monday. Haven't decided yet. I kind of gauge how conic systems goes that week. And we might even break it up into because it's a longer test. We might even break it up into a 2-part test and do part of it on Friday, part of it on Monday. So and then after that, then it's reviewing for your finals the rest of that week, and then your final in here will be on Monday, May 15th, part 1. Part 2 will be on Wednesday, May 17th. Okay? It will be a 2-part final, and you will be on those. And so really, we're talking that is 3 weeks away. 3 weeks. 3 weeks from today. 3 weeks from today, you'll take the final. Okay? Because I got to do them in class. Seniors don't get finals like 3 days of no school final type things. You got to take them in class. Okay? So we got that going. So we got 2 weeks worth of stuff, week of review, and then all right, let's do it. Now, a lot of this stuff on this next slide, you already have written down on your supplemental note sheet. Okay? If you don't have it written down on your supplemental note sheet, you're going to need to do some scribbling real fast here. Okay? So, on this one slide, I have the 4 general forms for each of the conics, or the general forms for each of the 4 conics, I think would be a better way of saying that. Okay? So for a parabola, remember we have 2 different forms, one for a up and a down, up or a down opening parabola, one for a left or a right opening parabola. And with a parabola, the 4 key parts that you will also need to find are the directrix, the focus, the vertex, and the axis of symmetry. Okay? That was from 4 weeks ago. That was the oldest. That was the first unit we started with a month ago. Okay? Then we moved on to circles, and we did circles 3 weeks ago. Okay? And so we did of the equation of a circle. That's the nice one because there's only one of them for it. And 2 key parts that you need to find on that, center and a radius. Okay. An ellipse we did 2 weeks ago. Again, it was nice because there's only one equation or form, general form of it. But the 5 key parts that you need to find out of that are the center, the 2 foci, and the 2 vertices. And then last week we worked with hyperbolae, if you will, and 2 different forms. Again, we had a left and a right opening hyperbola, or we had an up and a down opening hyperbola, and the 7 parts that you had to find for that: center, 2 foci, 2 vertices, 2 asymptotes. So those are the key things that we're going to need to find. And this week, as you can tell by the homework that you grabbed, the front side and the back side kind of coincide. So on the front side, you have 10 different conic sections. You just have to figure out which one is which And then the goal of this week is you're going to take them from how they look on the front side of your homework, and you're going to put them in their general form. Okay? So we have that. Now, with that being said, tomorrow there is an 11-minute video that you have to watch. Okay? You have to watch it. Otherwise, on Wednesday, you are going to be lost. And I am not going to show any sympathy for you on Wednesday because I'm telling you that you have an 11-minute video to watch at some point in time between now and you having class on Wednesday. It's already posted on Canvas. It's all ready to watch. It's 11 minutes. All I'm asking for you. Today, you'll get done with the homework that you can do today in about 45 seconds. You'll have the type of conic, that's all you're going to get to today on the front side, the type of conic, you'll have that done in 45 seconds for all 10 of them. Okay? So to replace that extra homework time, I'm giving you a short video to watch tomorrow or sometime before Wednesday to make it easier so we don't have to waste time on Wednesday with doing something, it's a topic that you've already learned. Okay? All right? So, here is how. Now, this is brand new. Now, this, if you're following along in your notes, you should probably put this in your notes. And this would be something that you can either write in each of your boxes on the front side, or something that you would definitely want to put on the back side of your supplemental note sheet. Okay? So here is how you can tell what conic is what based off of like equations like the front side of your homework. Okay? So first off, there's one easy one to differentiate. Okay? And that is the parabola. The parabola is the only conic that only has one squared variable. Every other conic has an x squared and a y squared. A parabola only has either one of those, either x squared or it's y squared. Okay? So when you're looking at an equation, like for instance, when you're looking at these, if you look at the squared terms, that's going to be your first thing that you're going to look at. Is you're going to count the number of squared terms. If you get to 2, it's not a parabola. If you never get to 2, it's a parabola. Okay? All right? So a parabola only has one squared term in it. Okay? That's the easy one to find. We've done it. Okay? The next easiest one to find is the hyperbola. And the hyperbola is easy because one of the 2 squared terms has a negative sign in front of it, has a subtraction sign in front of it. It's x squared minus y squared, or it's 9x squared minus 4y squared. It's something like that. Or it's 17y squared minus 5x squared. Okay? A subtraction sign separates the squared terms. Or conversely, or I shouldn't say conversely, another way of saying it, one of the squared terms is negative. Okay? So those are the 2 easy ones, because those are the 2 most distinct, most distinct conics. The other 2, circles and ellipses, are very, very similar. And the only way that you can tell the difference between them is when you get the equation set equal to 1, the denominators below x and y are equal if it's a circle. They're not equal if it's an ellipse. And we'll get in hardcore into that come Wednesday. Another way of saying that exact same thing is that in an ellipse, the coefficients, refresh my memory, what does the term coefficient mean? Number in front of the variable. So the coefficients on the squared terms are different in an ellipse. They're the same in a circle. They're different in an ellipse. Coefficients of the squared terms. Okay? So, to recap this slide, it's all about the squared terms. If there's only one squared term, what is it? Parabola. If there's two squared terms, you've got three choices: hyperbola, ellipse, or circle. Okay? If it's a subtraction sign between the squared terms, hyperbola. If the coefficients of the squared terms are the same, if they're different, ellipse. Okay? Okay? With me? Okay? Those four. So with that being said, what I would like you to do now is these four, they're different than what's on your homework. Okay? These four, I would like you to classify each conic section. Okay? Based off of the given information. Which basically is just saying, tell me which one's a hyperbola, which one's a parabola, which one's an ellipse, which one's a circle. Or multiple of them. No, it can only be one. No, let's worry about homework. When it's homework, don't worry about time. Okay? Because when we go through this, you'll see how to do that. Okay? Alright? So, we'll take the easy one first. Which one's the parabola? Why C? There's only one squared term here in C. There's no other squared term in C, so that one is the parabola. Okay. Hyperbola. Which one's the hyperbola? Why A? Because you're subtracting the two x squareds, right? Because of this right here, you've got 6x squared minus 2y squared. So that's a subtraction of the negative sign, or of the squared terms. So that is your hyperbola. That leaves circle and an ellipse. Which one is the circle? Why D? The coefficients are the same. We have x squared plus y squared in both. But here, in this one, the coefficients are the same, so that makes it a circle. Here, the coefficients are different, so that makes that one the ellipse. Alright? Now, our goal by the end of class on Wednesday, the goal is to be able to take an equation like this and put it in each of those standard form. Okay? And then from there, we can graph it, and find all of the key points like we've been doing for the last month. Okay? So that's the goal after Wednesday's class. Today's goal is I want to go back and I want to figure out how to write the equations and use those general forms of the conics again, because, for instance, here in F, you haven't done that for 4 weeks. Okay? In E, you haven't done it for 3 weeks, and so on and so forth. So what I want to do is I want to go back and I want to do this. Okay? So first off, gonna start with, it tells you in this one that we are dealing with a circle. What is the general form for the equation of a circle? Okay. H is what? So it'd be minus 3, right? Because H is really 3. Okay, so it's going to be minus 3 when we get there. K is what? Negative 2. So when I put it in the equation, though, it becomes positive 2. Okay? And if R is 4, what is R squared? 16. So this equation, this general form, is going to be x minus 3 quantity squared plus y plus 2 quantity squared equals 16. Does everyone agree with that? Okay. What I'm telling you, and here is what this is, like this week is all about. What I'm telling you is if I were to do this multiplication, if I were to do x minus 3 quantity squared, I would get x squared minus 6x plus 9. If I were to do y plus 2 quantity squared, I would get y squared plus 4y plus 4. And that would equal 16. So another way of writing this circle, which this is what you've had done, or this is what you found so far. Okay? So another way of writing that same thing would be x squared plus y squared minus 6x plus 4y. What am I at? Plus 13. Plus 13 minus 3. Those two are saying the exact same thing. You've been dealing with this box up to this point in time. Today, starting today and this week, now you're going to get it like the orange line down here and asked to do the exact same thing. Graph it. In this case, because it's a circle, find me the center, find me the radius. Okay? Based off of now, instead, this equation. Okay? So with that being said, you now find me the equation of a parabola with a vertex at negative 2 comma negative 4 and a focus at 4 comma negative. So we've got a vertex at negative 2 comma negative 4, and then we've got a focus at 4 comma negative 4. Which tells me that this distance here is 6. And that distance, remember, is P. So we've got a left opening, a right opening parabola. A right opening parabola has y minus k quantity squared equaling positive 4p times the quantity x minus h. So that would then be y plus 4. 4 times 6 is 24. X plus 2 would be the general form of it. If we were to expand that out to this week, the same we would have here, y squared plus 8y plus 16 equals 24x plus 48. So we would say here then y squared plus 8y minus 24x. Oh, would that be negative 32? Would be this week's way of writing that exact same thing. Okay. Find me the equation of the ellipse with that and a hyperbola with those. So if I have, in the first one, if I have vertices in between, or so it looks like they are left and right. So that one's going to be at negative 1, 5, and this one's going to be at 7, 5. Halfway in between them would be the center. So the center would be at what? 3, 5. That makes it 4 to each side. Yeah? Then I've got my two foci in here and in here. Okay. So this distance here is 4. This distance here is 2. The general form of an ellipse is going to be x minus h quantity squared all over a squared plus y minus k quantity squared all over b squared equals 1. What is a? A is 4, so a squared would be 16. Yep, okay, I'm with you on that. So this would be x minus 3 quantity squared all over 16 plus y minus 5 quantity squared all over what's b? Do we know b yet? No. What's the formula that we use in an ellipse to find the foci? So my c squared would be 4, because c is 2. And that's going to equal 16 minus something. Oops, I put a parenthesis there. Put an absolute value. 16 minus something. What would that minus something be? You got two choices to get it with an absolute value. What could fill in this gap right here? Two choices. 20 or 12. So your two choices are 20 or 12. There. One of them is right. Which one? Why? Because the vertices are on the major axes, right? Major axis is horizontal, so 16 has to be the biggest number. So 20 gets thrown out, 12 wins the day, and we get that. Okay. Now, to convert that into this week's equation, first thing I'm going to do is I'm going to multiply everything through by 48. So then I would have 3. That, and then this would be then we have 3x squared minus 18x plus 27 plus 4y squared minus 40y plus 100 equaling 48. And then we would have 3x squared plus 4y squared is 18x minus 40y plus 127, so that's 21. So that's going to be what? Plus 89? No, 79. Oh, 80. Well, that's 79. Can't do math. 21. So that would be that one. Okay. Hyperbola now. Whoa, not too far. Hyperbola with vertices there, so that looks like a up and down hyperbola. Because I've got a vertex up here at 7, comma 1. I've got a vertex down here at 7, comma negative 3. That would put my center right here at 7, comma negative 1. A distance of 2 there. That would put my foci up here and down here. So this distance here would be, that's what, 7, comma negative 6. So that distance there would be 5. Formula for the general form, I should say, of an up-down, is it x squared or y squared first for an up-down hyperbola? Y squared first. So that's going to give me y plus 1 quantity squared all over 4 minus x minus 7 quantity squared all over, do I know what a is yet? Do we know a? Not yet. What's the formula that I use? C squared I know is 25. B squared I know is 4. So A squared would be 21. So we have 21 times y plus 1 quantity squared minus 4 times x minus 7 quantity squared equaling 84. And then we have that. And so then that would give us 21 y squared plus 42 4x squared plus 56x minus 160, no, plus 196 equals 84. Then we could say here then negative 4x squared plus 21y squared. Now this, the reason I wrote it this way is because this still signifies a hyperbola. Okay? Even though it's not a subtraction sign in between them, one of the x squared or one of the squared terms is negative. That still signifies a hyperbola. Okay? And then plus 56x plus 42y, positive 21 minus 84 is negative 105, negative 201, negative 3. Still signifies a hyperbola, even though there's not a subtraction sign, because the 1 is negative. Okay? Again, I remind you of the fact that there is a very important video for you to watch. It is 10 minutes and 51 seconds long. Okay? You should take notes on it. You should watch it. If you don't understand it, watch it again. Okay? Ask questions about it. That information you will use Wednesday in class, Thursday in class, Friday on the formative, next for 2 weeks on the test, on the final. You'll use it in all of those spots. Okay? So watch that video and take notes. It is posted already on Canvas. It's ready to go. It's under tomorrow. If you look on the agenda, scroll all the way down to the bottom, it's on tomorrow. It's the link is there to watch it tomorrow. I think I even got it set up so that the link is, you can play it right in the agenda too. I think I was that, technologically savvy.